Okay, so if I got you excited with 1.1 being so easy, don't worry, 1.2 is not as easy. It's not that big of a deal, it's not that difficult, but you have to remember the difference quotient from advanced functions, or I mean, it's really grade 9 slope. So if you want to find the slope of a tangent, which is the basis of calculus, you want to find instantaneous rates of change, slopes of tangents around curves. We're going to use a rational function here. We want to find the slope of this tangent at this point. So however this function looks, at that point, there's going to be a tangent, and we don't know how it looks, and we don't know what the slope is. But we have to figure it out. So what we do, we recall the difference quotient. Now this is going to morph to look like a little different in calculus, but I'm just going to make it this way to remind you of advanced functions. And remember, we can't use an h value of h.01 or whatever it is, right? Because we have to stick to the h value that exists. So what we want to do is we want to find out the a value is just going to be the x value. Now we're lucky that it's giving us a point, or else it could just say at x equals 2, and then we have to plug in the 2 to get the 6. So there's a bit more information here than usually questions give us. So this is f of 2 plus h minus f at 2 all over h. And I know what f at 2 is. All I have to do now is find what f at 2 plus h is. Well, to do that, I have to plug in 2 plus h into the x values here. So I'm going to say this is 3, 2 plus h plus 6 over 3, over just 2 plus h. I'm going to subtract f at 2, which is 6, and this is all going to be over h. Okay, now, every time I do a step like this, when I'm doing slope of a tangent, I don't care if it's a rational function, a root, there's a bunch of simplification you have to do here. You have to math out once you substitute. So here, it's a fraction. So I'm going to have to multiply this up here to actually add and subtract my fraction. I have to multiply this 3 inside here. I have to combine the 6 with that 6. There's stuff to do. So I'm just going to go here, and I'm going to do as much stuff as I can. This is going to be 6 plus 3h plus 6 minus 6, 2 plus h over 2 plus h. I'll keep it in 2 separate denominators, all over h. Now take a look. I've multiplied by 2 plus h, and now I have to divide by 2 plus h, just adding and subtracting fractions. Now I have to distribute that in there, collect stuff. It's not that difficult. I should have called that a 12, but it's okay. Negative 12, negative 6h, mistake alert right there. That negative 6 has to multiply inside. And this is all over 2 plus h. Now, if I have a common denominator on top and it's like over h, I can just put that h down here, because dividing by h is like multiplying by 1 over h. So it's the same thing as doing this times 1 over h. So what I do is I just slap that h in the bottom, and there you go, combines it. Now let's clean up the top. Something very interesting here that you should always be alert to: all of your constants should equal 0. If they don't, you're wrong. So 6 plus 6 minus 12 is 0. Awesome. 3h minus 6h is negative 3h over h, 2 plus h. Now that I have a monomial on top, I can finally cancel out my h's, and I'm going to have my answer here. Not really an answer. You know what? I'll keep going. M is negative 3 over 2 plus h. Now I can actually plug in 0 into h, and it's obvious that when I plug in 0 into h, I get m is negative 3 over 2. So the slope of the tangent at that point on this graph is negative 3 over 2. Okay? Might look intimidating, this process, but it's the same every single time. When you do a rational function, this is what you do. I'll do a root function next, because probably have to multiply by the conjugate, but it's always the same type of stuff. The constants cancel out. It's no big deal. Okay, so in this question, the same idea, except we have a root function now, root x, and we want to find the slope of the tangent at x equals 9. So here again, the difference quotient, memorize it, write it down, don't make a mistake. And now I'm going to plug in the things that I know. Well, that's just the a value. So I'm going to say that this is f of 9 plus h minus f at 9 over h. And now I'm going to plug in these values into the function. So this is going to be root 9 plus h, make sure both are in the root, minus root 9 over h. Yes, that's a 3. So I can rewrite that here. I think should have, you know what, I'll go here. This is going to be 9 plus h minus 3 over h. And now I'll bring it up here. What a waste. Because I want to show you the multiply by the conjugate step. So now, there's nothing I can do here. Like, I can't cancel out an h, I'm stuck. So because I'm stuck, rationalizing comes in handy. Now, I told you before that we usually like to rationalize the denominator because we simplify it, but there's nothing else I can do here. So multiplying by the conjugate is kind of like you're in a corner and you have to jump out and it gets you out. So what that does, if I multiply by the root of 9 plus h plus 3 over the root of 9 plus h plus 3, remember they have to be the same because this is a value of 1. What that does is the numerator gets squared and unlocks that h. And this h doesn't get rooted, right? So I have an h over an h, and I can visualize that already. So take a look at this. This is a plus b and a minus b. So I'm left with 9 plus h minus 9. There's my difference of squares from the numerator. And in the denominator, I never multiply the h inside, just keep it out. This is 9 plus h, make sure the root extends over the h, plus 3. Look at the top. Constants cancel out. So I have h over h, root 9 plus h plus 3. Now, h's cancel out. That's what I'm looking for. So my slope right now, let's go this way, is 1 over root 9 plus h plus 3. Looks like a disaster, but all I'm doing here is trying to plug in 0 into h, and I can't do it here because I'm going to get an undefined answer. As soon as I can do it, I get it done. This is going to be 1 over root 9 plus 3, which is 1 over 3 plus 3, 1 over 6, and I am done. The slope of the tangent of this root function at x equals 9 is 1 over 6. That makes sense, right? I mean, the root function looks like this. 9 is like over here, should have a positive small slope. Yeah, sure, makes sense. Okay, no big deal, but take a look. You have to have this skill in your back pocket. You have to use it when you are stuck. Okay, rationalize.